Officially, energy is the capacity to do work. When a force causes an object to move a distance, work is done. Power is simply the rate at which work is done. Now, what does this really mean? It is easiest to define these terms through an example.
Let's think about cars on a drag strip. Let's assume we have two cars that weigh the same, but one has a turbo and the other doesn't. As they weigh the same amount of energy is required to move them to the end of the track. Now, you would expect the car with the turbo to win the race. Why? Because it is more powerful. In other words, it can perform the work necessary to get the car to the end of the track in less time. Here is a real-life example.
The same principle can be applied to electricity. In order to move a charge, we need to apply a force.
We can express this mathematically. We know that voltage equals energy divided by charge, and we know that current equals charge divided by time. If we multiply these quantities together, we get voltage times current is equal to energy over charge times charge over time. The Q's will cancel, and we get voltage times current equals energy over time. Now we know that energy over time is power, so now we have an electrical relationship for power. So we have P equals V times I. By rearranging Ohm's law, we can find some new relationships between power, resistance, current, and voltage. These include P equals I squared R and P equals V squared on R. This example is going to use most of the concepts that have been covered in this video. As we can see, we have a 120 volt power supply and we have a combination series and parallel circuit. Now we need to find the total energy consumed by this circuit over 1 hour. We start this problem by finding the total resistance. This equals 6.2 ohms. From here we can see the total power to be 2.32 kilowatts. Finally, we know that power equals energy over time, or energy equals power multiplied by time. Now our time period is 3,600 seconds and our power is 2,320 watts. So in total we get an energy of 8.36 million joules, or 8.36 megajoules.
To summarize this video, we use the relationship between power and energy, so P equals E over T, along with Ohm's law, to develop some equations that are going to be very useful to help solve electrical engineering problems.